All right, welcome. Good afternoon, good morning, good evening, wherever you're coming from. It takes a couple minutes for all the attendees to get in after we open the session, so we'll give people a little bit of time. See Alan in there. So we're going to get started in about a minute. Just while we're waiting for a few more attendees. Oh, here we go. Promote to panelist. There we go. I think that did it. Okay. So just before we get started, this is one in a series of 6 AWS Discovery Days that we're doing at ExitCertified. And this is the 5th one. There's one more next Wednesday. Also on Gen AI. The earlier ones, where there was one just on basic kind of cloud essentials, and then 3 of them on kind of the analytics stack that I did myself. Today, we have one of our Gen AI experts, Mike Bitar, is going to be teaching today's session. And so he'll do a bit of an intro to himself in a minute. If this is your first time dealing with ExitCertified, we've been in business for over 20 years. ExitCertified has traditionally been kind of partnered with large vendors like AWS, who have a training program. And they certify our instructors, and we help them scale to deliver these classes to all their customers. We're also partnered with, Microsoft and Google and IBM and VMware and Oracle. About a year ago, we got bought, and now we have 2 sister companies that also do instructor-led training. Accelerate has often done, sort of a lot of open source and programming language type training, things that are not, necessarily coming from a vendor. And WebAge Solutions builds a lot of their own content, and it's they concentrate a little bit more on upskilling kind of programs where maybe you have new hires and you're going to send them through a 4, 5, 6 week program to become, maybe data engineers or something like that. And so now we have the power of all these organizations together, and so it allows us to really open up what our offerings are. And we have maybe a quick intro from our AWS partner manager, Alan Middleton. So Alan, if you want to just maybe say a few words, and then we'll introduce Mike.
Absolutely. Hey, everybody. And thanks for your time today to kick off today's Generative AI Essentials session delivered by my friends at ExitCertified. I'm Alan Middleton. I am a Senior Partner Development Manager here at AWS in North America. Organizations of all sizes and types are harnessing large language models and foundation models to build generative AI applications that deliver new customer and employee experiences with enterprise-grade security and privacy, access to industry-leading foundation models, and generative AI-powered applications. AWS makes it easy to build and scale generative AI customized for your data, your use cases, and for your customers. The first step, of course, is learning all about it. And you have definitely come to the right place for that. So ExitCertified is one of AWS's very best training partners, having been named Partner of the Year and having trained thousands of AWS builders over the last decade. You'll learn a lot today, but it's only the very beginning of your learning journey on AWS Gen AI. Enjoy the content and stay connected with ExitCertified and the team there as they guide you through and guide you forward by using all of the AWS blended learning tools that are available to you. So thanks, Miles.
Thanks, Alan. Really appreciate you dropping in. Now I want to introduce Mike. Mike is going to be our instructor for today. And in fact, I'm going to drop into the chat. You can feel free to ask questions in the chat. I'm going to be sort of manning the chat. If there's things I can answer, I'll answer them. Otherwise, I'll get Mike to answer them. but I'm going to start by dropping in some of his credentials. So he has a lot of AWS and Google Cloud certifications. He's got TensorFlow. He's got NVIDIA certifications. He is a Gen AI expert in a way that I am not. So we get Mike to do these ones. So Mike, I guess you could take it away, and maybe you want to share your slides now, right?
All right. Thank you, Miles. You're being modest. Again, thank you all for joining us today. Name again is Mike Bitar. Let me just share my screen here.
You're sharing the desktop.
Desktop, yep. Let's see, stop sharing. Sharing screen 2. All righty.
Perfect.
Are we good?
Yep, perfect.
Awesome. Thank you. So this is a webinar on the generative AI essentials for business and technical decision makers. And it's a high-level overview of some of the latest developments in generative AI, especially as it relates to Amazon Web Services offerings. And again, the emphasis here is on business and technical decision makers. So module 1, we will introduce you to some of the basic fundamentals of generative AI, the art of the possible. The outline for module 1. So in this module, we will cover, like I said, a high-level intro to generative AI and what makes AI special. And we will also go through some of Amazon's 20-year journey through machine learning up until generative AI and beyond. So what is generative AI? So generative AI is a rapidly evolving field. It's definitely not a recent one, but I think it picked up tremendous momentum about, I would say, a year ago, give and take. And then, it's been snowballing. If you are like me, and if you're keeping track of the latest developments, following the latest podcast, product releases, it's been breathtaking. I mean, just the level of excitement in this field, the rapid evolution of generative AI, the breadth and depth. We started with text to text. Now we're basically seeing text to video. We're seeing generative AI models that are incredibly sophisticated on multiple fronts. From code generation to Q&A to different aspects of generative AI. So let's just demystify some of the terminology and some of the concepts here. So what is machine learning? So traditionally, if you go back, I would say over maybe 10, 15 years ago, machine learning was considered pretty much a field that was considered a field that relied heavily on data, specifically labeled data. And then we fed that labeled data to train models. And then those models recognize certain patterns. And those patterns could be, for example, forecasting, categorizing, coming up with a range of values. And then we use those trained model to make predictions. And those predictions could be, for example, the value of an item, the category of an item. It could be, true or false, yes or no answers. And the whole domain of machine learning just exploded. And that was before generative AI. And we had different applications for image processing, for audio processing, for natural language processing, and so on and so forth. So what is different between, let's say, traditional machine learning and generative AI is that with traditional machine learning, we feed our models, like I said, data sets, scrubbed, cleansed data sets, typically labeled data sets, but not necessarily. And then we feed that cleansed data to a model, and that model can be a neural network. And there are different variations of these neural networks. And those neural networks constantly evolve and improve. We validate the outcome of the training process. And once we're comfortable with the level of accuracy of those models, and there are different parameters, of course, and different metrics that we need to tweak, then we deploy those models to make predictions, either batch predictions or near real-time predictions. Unlike the traditional, if you want to call it machine learning, but unlike the traditional approach to, let's say, machine learning, applications in the past tend to rely heavily on if-then-else rules. It's a lot of hard-coded rules. I don't even know if you can even call it machine learning, but some of the legacy systems actually were generous enough to call themselves machine learning systems, but they were not. Because what makes machine learning special is that we are learning from data. We are not hard-coding rules. So classic expert systems, if you want to call them that, relied heavily on if-then-else rules. A lot of hard-coded rules, a lot of string processing, not with machine learning. With machine learning, the emphasis on taking data sets, prepping data sets, labeling data sets, if we're talking about supervised machine learning, and then coming up with trained models, and then using those models to make predictions. So let's talk about the history of machine learning at Amazon. Amazon actually was one of the early adopters of machine learning. And that makes sense. I mean, if you ever try to purchase an item from Amazon.com, then you're familiar with the recommendation system. And basically that uses machine learning behind the scenes to make intelligent recommendations for customers. Typically, when you place an order for an item on the Amazon.com portal, you will see things such as other customers bought XYZ. You will see recommended items or suggested purchases. So that relied heavily on machine learning algorithms. In 2005, Amazon Prime was launched, and also that leveraged machine learning to also make recommendations. Then Amazon started using robots in their fulfillment centers. You might have seen some of those videos where you see those robots, sort of like orangey, yellowish robots on wheels. And what they do, basically, they pretty much help move items, help with fulfillment of items, and they do it quite rapidly, and they do it rather accurately. In 2014, Amazon launched Alexa. Most of you are familiar with Alexa in one shape or form. Alexa basically falls into the category of limited chatbots, limited capabilities chatbots, and as you've seen since the explosion in large language models, chatbots have taken a tremendous step forward because of generative AI. Then Amazon Prime now launches, followed by Amazon Prime Air to make its first delivery using drones, heavily relying on image and video processing. Then Amazon Go was launched, and Amazon Go is those, sort of like, think of them as like highly intelligent supermarkets where you walk in, pick items from the shelf, put them in your basket, walk out, and then everything is taken care of for you. You don't have to stand at checkout lines and so on. A subsidiary of Amazon called Zoox also launched its first autonomous robotaxi. And in 2023 and beyond, Amazon launched Code Whisper, which is Amazon's generative AI for code assistance, okay? And Amazon Bedrock, which is Amazon's fully managed generative AI development service, where you can basically deploy pretty complex stacks for generative AI applications with nominal coding, But you still have other solutions like SageMaker, Jumpstart, and SageMaker, if you wish to take full control of the process of developing and deploying generative AI applications. So where does generative AI basically fall into the whole equation of artificial intelligence? Well, it is a subset or a subdomain of artificial intelligence. So to help you sort of like visualize the different layers, the different domains, and where generative AI belongs, so you have this artificial intelligence. This is like the all-encompassing domain. And then under that, or a subset of that, you have machine learning. A subset of machine learning is deep learning, and that's where basically neural networks come in. And then we have generative AI. Now, the lines are not really clear-cut, and there might be some overlap, but hopefully this will help you conceptualize the sort of like the relationship between artificial intelligence and generative AI. Now, if you've ever been involved in developing or researching deep learning, you know that deep learning started that, I would call it the pre-generative AI revolution in machine learning that set the stage for generative AI. And that's basically the adoption, the wide adoption of neural networks. So let's talk about the evolution of machine learning and the emergence of generative AI. Why now? And when we say now, actually, it's like why 2-3 years ago. So the actual, remember we said that neural networks, okay, or deep convolutional networks set the stage for generative AI. So what happened all of a sudden? Yes, we did have machine learning actually more than a couple of decades ago, but something happened along the way recently over the last, let's say, 5-6 years that sort of like accelerated the growth of machine learning and led to the emergence of generative AI. Of course, the more obvious reason is compute power. So we have so many, let's say, so many developments in the realm of machine learning, accelerators, be it in the form of GPUs, such as the ones manufactured by NVIDIA, or in the form of, let's say, dedicated hardware, such as the ones that were designed by Amazon, talking about Inferentia and Tranium and others. So we have this, like I said, massive boost in compute power for training large language models. And then on top of that, we have access to massive data sets, some open source, some you can license, some labeled, some not labeled. So there is again, there are repositories of data sets today that are accessible to data scientists that were not necessarily accessible over a decade ago. Some of those are internet scale data sets used, for example, to train some of the large language models that you might be familiar with. Also, willingness to go big, willingness to explore different ideas. Also, the number of how can I say, parallel development or parallel R&D. Today, there are literally thousands of universities and research institutions that are working hand in hand, sharing knowledge through academic papers, through AI conferences. That's also helping boost the rate of development for AI in general and for generative AI in specific. Just rapid growth, rapid evolution. And if you're constantly following, the latest in terms of generative AI, academic research, then you understand how hard it has become to actually keep up with it if you're a generalist. Investment in team sizes. We actually today, we have I would say, a new corpus of experts, of machine learning experts. In the past, machine learning, you could pretty much, you can be a data scientist and you can sort of like find yourself in on a machine learning project. That was the case for me. But today, there are actually so many specialists in machine learning, quality specialists, trained both academics and ops folks, that also, so all these factors coming together that help pretty much spur the growth of machine learning and basically sort of like lead the charge in generative AI. Interesting times. So generative AI is not really new, but generative AI in its present form, I think is about 2 to 3 years old. Generative AI is a term that you can apply to AI that can create new content, including conversations, stories, images, videos, music, code, etc. We had those capabilities actually a while back before we coined the term generative AI. That those features did exist in to some extent in classic machine learning models. But they were not at the level of sophistication that we see today. The level of creativity, the level of the evolution, to the point where some of those large language models, a name for those models that we use as the foundation for generative AI, some of those actual large language models have on various benchmarks have performed incredibly well as compared to expert human beings who are expert in different domains, from image recognition to music generation to fiction writing and so on and so forth. And that actually reminds me of a scene from a movie starring Will Smith. It's a bit of an old movie now, and I think it was made pretty dated with the evolution of generative AI. Will Smith was having a conversation with a robot, and Will Smith hated robots. So Will Smith, wanted to put the robot in its place. So basically, he told the robot, can robots make poetry? Can robots draw paintings? Can they make art? And so on and so forth. Now, back in the days when you were watching that movie, you were rooting for Will Smith. Like, yeah, that's definitely not going to happen anytime soon. Fast forward, I looked at that scene from the movie, and yeah, pretty much AI, with the help of generative AI, can pretty much write poetry, can generate interesting paintings, can write fiction novels, and do much more than that. Now, you might not consider that creativity. I mean, that's a subject that's open for debate, but things are happening and are actually evolving quite rapidly in a direction that's making some people uncomfortable, but other people basically are embracing the change. So generative AI is a type of AI that can create new content. Just a quick show of hands. How many of you have worked with some of the text-to-image models? How many of you have worked with text-to-image models? Okay.
I'm not sure if we can show hands. Hold on. Raise, allow. Okay. Yes, they should be able to raise their hand now.
Okay. Awesome. Thank you. Yeah. I mean, some of those are free. Some of those you have to pay for, like Midjourney. Some of those you can download, like Stable Diffusion, and you can generate images using your own personal workstation or virtual machine on the cloud. Absolutely fascinating. So, but another thing that actually that sort of like came out of this generative AI revolution, if you want to call it that, is code generation. So we might have had a semblance of code generation, a few years ago, but again, it wasn't at the level of sophistication that we see today. And for example, Amazon's code generation service is called Code Whisperer. There are studies actually that showed that 27% of the developers were more likely to complete tasks successfully. 57% of developers are faster than those who are not using Code Whisperer. So Code Whisperer is Amazon's managed code assistant, code generation service. And not only that, it can also check your code for certain, let's say, against certain security rules to identify and flag syntax that, for example, that might lead into security issues in a production environment. And we are seeing Code Whisperer grow in sophistication, as with other generative AI models, to the point that today, personally speaking, I will not sit down to write a script without the help of Code Whisperer, because before Code Whisperer and code generation tools, I used to make multiple trips to Stack Overflow and other websites, as well as a repository of code that I kept refreshed on an ongoing basis, keeping just snippets of the latest and greatest code that I constantly use. Now I don't have to do that anymore. I just use Code Whisperer, say, hey, Code Whisperer, write me a script, let's say in Python, that will upload, let's say, a folder with its subfolders into an S3 bucket with the following name. Okay, quick and dirty codes that we write all the time to get the job done. But sometimes, if we haven't written code in a while, we may have to go through this initial period of constantly Googling until we get our bearing, or again, look for some, sample code repository. Now, with tools like Code Whisperer, I can literally just go in and on the fly add a comment, and in that comment, basically, describe what I would like Code Whisperer to sort of like help me with, and it will generate, sample code. Now, that does not replace the coder. I still have to use my judgment to assess the quality of the code. So, folks said, well, that's going to replace programmers. Not anytime soon. Someone still needs to be responsible for making that call that says, okay, this code snippet, this looks good. I'm still going to test it to validate that it basically delivers the output that I'm looking for. Will things change in the future? Who knows, right? Everything is up in the air. But this is one example where code generation actually has shined in terms of improving the productivity of developers and IT workers in general. But there are common use cases, and if you've worked with generative AI tools in the past, or in the last few months, you probably have been, let's say, have had some experience with chat tools. You have used maybe generative AI as a virtual assistant. You may have used it as an intelligent contact center for personalization, content moderation, search, content creation, text summarization, code generation. And on the creative side, we have seen, of course, generative AI generate, let's say, visual art, but also generate music with lyrics. Yep, we actually have that. Of course, generate poetry, tell stories, create animations, and we are seeing tremendous strides in the field of text to video. Really, really fascinating possibilities there. Imagine having just to sit down and write a few paragraphs and generate a scene, either a video scene or an animation scene. That's no longer how can I say far-fetched. We are already seeing some experiments, maybe with limited capabilities, where you can today generate some animation, some video with varying degrees of quality. But we are seeing a trend, and it's a really, really, really accelerating rapidly, where the quality of generating video, animations, images, music, the quality actually for most people can be indistinguishable from human-generated content. And other aspects such as document processing, maintenance assistance, quality control, visual inspection, synthetic training, data generation. And this is actually just a subset. So if you look for different use cases, if you Google, if you look for success stories, you will see this list growing very, very rapidly. People are getting very creative, coming up with all sorts of unique applications for generative AI. Common use cases. How Amazon uses generative AI? Well, Amazon uses generative AI in so many different ways, but one of those is this really nice tool. It's called Create with Alexa, where you can basically create stories, generate drawings, and you can communicate with it verbally. It's just really a pleasure to work with them. And there are some YouTube videos out there that you can, if you haven't seen that firsthand, you can basically check those YouTube videos. Now, generative AI services on AWS. So generative AI development is not really for the faint-hearted. Now, generative AI is different from classic AI or classic machine learning in a number of ways. Some are obvious and some less obvious. While in classic machine learning, you as the developer, the company, the project, tends to be responsible for the pipeline from the get-go, from obtaining the data, scrubbing the data, labeling the data, splitting the data, training, validation, testing, into selecting the hyperparameters, fine-tuning the model, and then generating the trained model and iterating on this process. In generative AI, you tend to work with an already pre-trained model. So only in very few cases will you be involved in training the model, okay, for generative AI. Most of us have worked with generative AI applications using already pre-trained models, okay? So with classic machine learning, again, you're responsible for the pipeline from data gathering or data set gathering, data scrubbing, feature engineering, splitting, hyperparameter tuning, iterating, validating, and all that stuff. That's typically your responsibility also, up until the point of training and deploying the model. Okay, generative AI, you are working with a pre-trained model. So there's a different pipeline involved in generative AI, okay? And we are seeing, ML ops evolve to pretty much adapt to this new age of generative AI. For example, some of the things that you might end up doing with generative AI is something called prompt engineering. And we have a webinar coming up soon. And prompt engineering is a fascinating field. When I first heard the prompt engineering, I assumed that this has got to be something, silly. You just go in, you type a prompt, and if it doesn't work for you, just modify the prompt, and you keep trying again and again until you get the output that you want. Well, as it turns out, prompt engineering today is a specialty. There are actually academic papers focused on prompt engineering, and prompt engineering is such a generic term today. For example, there are papers that benchmark the results of how you word and how you structure these prompts. And there are different concepts and methodologies such as zero shot, multi-shot, train of thought prompts, tree of thought prompt, and then chain of thought prompts, and react prompts, act prompts, self-consistency prompts. There's a whole field of research just focused on how you structure your prompt before you send it to your large language models. And some of that research actually shows a significant improvement in response from the large language model when you basically format your prompt in a certain way. So I urge you to attend the prompt engineering webinar. It will be quite enlightening, in my opinion. So with generative AI services, because generative AI is a relatively new field, many developers are just basically finding themselves like, where do I start? How do I consume a large language model? Do I have the infrastructure, basically, that can host a large language model? And some of those large language models actually are quite substantial. And unfortunately, you can't just download them on a virtual machine, for example, on your local computer and use an NVIDIA 4080 or 4090. And you can do it with some of the lower end large language models. But if you want to basically consume some of the high end large language model, you will need a fleet of GPU accelerated virtual machines, and you will need an ecosystem of software and libraries, and you need to basically understand the process of how to chain the stack together to be able to deploy a generative AI application. So AWS basically said, what, we're going to give you this fully managed service called Amazon Bedrock, where literally you can deploy complex generative AI solutions with minimal coding, or in some cases, absolutely zero coding. And not only that, we will basically give you your own isolated environment, and we will not use your data that you are using to train or prompt your large language model. So we're going to give you an isolated large language model. We're going to keep your data in. We're not going to use it for training. We're not going to pass it to the vendors. It is yours, and will allow you to apply the whole AWS ecosystem of security, privacy, from encryption to identity and access management, and so on and so forth, to CloudWatch logging, to audit trail API tracking. So that's Amazon Bedrock. It's a fully managed foundation models as a service. Okay, foundation model as a service. Now, if you want to take more control of your generative AI stack, then AWS has Amazon SageMaker and Amazon SageMaker Jumpstart that also allow you to deploy large language models in the cloud, but then you have basically access to more bells and whistles, more knobs to tweak and optimize. And if you're familiar with AWS, it's sort of like, the difference between a fully managed service, let's say like Lambda, a semi-managed service like, Elastic Container Service, and a non-managed compute service like, the EC2. So when it comes to generative AI, you have pretty much a similar spectrum of AWS services. So you have fully managed, and that's Amazon Bedrock, and you have, semi-managed, and that's Amazon SageMaker Jumpstart. But you know what? If you want ultimate control, you can always, deploy it to a fleet of GPU accelerated EC2 instances and be totally in charge. And AWS supports all sorts of, GPU accelerated EC2 instances. In addition to controllers developed by Amazon, such as AWS Trainium, that helps you basically accelerate training of large language models in a cost-effective way, and AWS Inferentia that allows you to basically deploy models for inference, okay, also using a cost-effective compute infrastructure. So you have Trainium for training models and Inferentia for basically deploying models for inference purposes. And those are cost-effective solutions. But again, AWS also provides you with GPU accelerated instances using NVIDIA, if that's the preferred route. So you have this buffet of choices that you can pick and choose from, depending on the level of control you wish to exercise, the level of resources that you have, or the level of headaches that you wish to get rid of. So use cases for business. Again, this is a small subset, but today we are seeing so many different applications of generative AI. For example, there's digital scribe. Then we have personalized medicine, and we have medical imaging. So generative AI found its way also to the healthcare industry to help professionals in the healthcare industry keep track of, let's say, of patient records, to be able to analyze scanned images, to be able to identify, for example, any issues with medical prescriptions, and much more. Same thing in life sciences. We are seeing large generative AI support research in drug discovery, protein folding predictions, synthetic biology, and in financial services, generative AI is also helping with fraud detection mechanisms, portfolio management, debt collection, and much more. In manufacturing, product design, process optimization, preventative maintenance, material science. In retail, you have price optimization, virtual try-ons, store layout optimization, product review summaries, and for media and entertainment, content generation, be it audio, be it video, be it animation, virtual reality, news generation, and of course, like I said, the list is growing. The list of applications is growing rapidly, almost on a weekly or monthly basis. All right, so in this module, we covered the topic of what is generative AI and how does it fit within machine learning, a brief history of machine learning at Amazon, and some typical generative AI applications and use cases, okay, and how they deliver business value. All right, so let's move on to the next module, and that's the importance of generative AI. So we're going to basically cover generative AI practice, as well as a very important topic that I'm sure most of you have read about, such as risks and benefits of generative AI. So generative AI in practice, we talked about content summarization. That's when you feed, let's say, your large language model, let's say a report, let's say a book, depending on, again, the limit of this large language model in terms of inputs and outputs. You can feed it any source of content. And you can ask it to summarize, you can ask it to give you bullets, you can ask it to generate an outline, you can ask it to create abstracts. Yeah. And you can also ask it to perform content generation. So it can actually write summaries for you. It can write, descriptions of products for you. It can write, like I said, fiction and nonfiction. With, depending on the model, with mixed success, of course, with some of the lower end models, but with some of the newer, higher end models, we're seeing some tremendous results when it comes to content generation. Same with code generation. With some of the state-of-the-art high-end large language models, we're seeing LLMs generate games from a single prompt, or maybe a 2 or 3 iterations on that prompt. I'm sure some of you might have seen some of those videos where developers just go in and ask a large language model, says, hey, I want you to develop the code for solitaire. And I want you to use the keyboard, for joysticks. I want to keep score, and I want you to do this and this and this and this. Lo and behold, yep, some of those leading edge large language models can actually spit out the game from the first prompt. And then, of course, you have Q&A, large language models, be it general purpose Q&A, generative AI, such as the ones maybe we all use on a daily basis, or specialized Q&A large language models, such as asking domain specific questions. Questions about, let's say, your company's product, questions about a certain development in science. Now, there are limitations to large language models, and that's typically based on the data sets that they were last trained on. But then we are seeing some workarounds are actually quite sophisticated, including but not limited to retrieval augmented generation. More on that later. So content summarization. Here's an example prompt. I'm sure many of you by now have used large language models and have entered prompts. So you can go in and say, please use the detailed market research. So again, depending on the input limits that are available for large language model, you can enrich the context of the prompt by giving the large language model additional information to help it with the answer. And some of that information you can embed in the prompt, but for information that goes beyond, let's say, the limits of your large language model's input, there are other tricks that you can play, such as summarizing content and so on and so forth. Or if you prefer a more, let's say, automated approach, you can save your content, save your product information in a storage location, and then generate, let's say, a vector database from that data, and then use that vector database to enrich the prompt before you send it to the large language model. And that works great for data that the large language model has not been trained on, such as your domain-specific information. Content generation. Again, you can ask it to write a product description in this example based on some information that you have provided about this product. Here's an example output. Code generation, very popular application. And for content generation, by the way, depending on the modality of the model, some models will generate text, some models will generate images. So for example, in this case, we're talking about, let's say, something like maybe stable diffusion, text to text or image to image. In a text to image model, typically you would basically tell your model, let's say it's a stable diffusion model, say, I want you to give me an image, let's say, of a futuristic design for widget ABC. And you will be surprised, by the way, how creative some of those stable diffusion models can be in terms of generating visual arts. But you can also give it a photo or an image of an existing item and ask it to actually make variations from that original image. You can actually do that. So you can give it an image, pass to it a prompt, and in this case, you can say, stylize this photo as a product photo with background in London. Yeah, we can do that actually quite easily in some of the text-to-image or image-to-image generative AI models. And you can do much, much more than that. This is just a nice example. Code generation. I think most of you developers are probably familiar with it, but code developers, as I said, today, you can pretty much get your favorite code generation tool, mine is Code Whisperer, to improve your productivity significantly, so you don't have to constantly Google Stack Overflow or refer to Git repos for code snippets. I was able, for one prototype a couple of months ago, I had to spin up a reasonably sophisticated REST API backend using Python. And I could have done it in probably 2-3 hours, but I was literally able to finish the task for a demo in less than an hour. I knew what I was looking for. I knew what questions to ask, so I knew how to iterate on the request for code generation and code improvements. And as some of you are already familiar with, you can even paste an error message, and then some of these code generation, code assistant models can intelligently even debug and diagnose the problem for you and make suggestions. Yeah, it's quite impressive. Question and answer. We talked about that, such as maybe you have some interface that you wish to present to your customers, or maybe some HR portal you want to present to your employees. You can use large language models to perform Q&A. And if you have proprietary data, we mentioned that there are mechanisms where you can leverage that proprietary data, typically using something such as retrieval augmented generation, to enrich the response of your large language model on data that it has not been trained on. So there are so many workarounds to help your large language model answer questions about domain-specific data that it hasn't seen before. Now, we've all read about some of the risks and benefits of generative AI. With the risks, you have the usual regulatory requirements. And again, some of these risks, by the way, we're familiar with. Anytime you're dealing with data, anytime you need to meet certain rigorous requirements, compliance requirements. But with generative AI, we have to sort of like consider additional layer of uncertainty, simply because these models are non-deterministic, they're probabilistic. And one of the terms that you probably have heard is, for example, hallucination, toxicity. So the more sophisticated the large language model, the more high-end the large language model, the less you have to worry about these concerns. But not every project, okay, not every generative AI project is worth the expense of a high-end large language model. Some projects, a mid-range or a low-tier large language model will do the job, but you have to be aware of some of these issues and establish guardrails. Again, it's another area where Amazon Bedrock can help you with. So you have regulatory requirements, social risks, privacy concerns. You probably remember some of the headlines where folks went in. We're talking about first-generation large language models. You're hearing about that less and less. They were able to extract, some PII data from the large language model. It was, data that it was trained on, but it wasn't able to filter that data, before it presents it to the customer. Today, most large language models will have some sort of filters or guardrails to sort of like intercept any data that should not be presented to the customer. And there are, guardrails that are more sophisticated than others. More on that later. Benefits: personalization of customer interactions, generate novel content, easy to adapt pre-built models to business use cases. And when we talk about adapting pre-built models, we already talked about retrieval augmented generation, but there are other techniques of adapting models, using fine tuning, and you're going to come across terms such as low rank adaptation, VIAs, and so on and so forth. But that's for later discussion. Productivity gains through automation. Yeah, I mean, think of large language models as a personal, a specialized expert personal assistant. And some of those high-end large language models, they can actually pretty much knock off, I would say, 20-30% of my daily admin tasks, writing emails, summarizing papers, writing descriptions of products, prepping press releases, and so on and so forth, updating website content. Yeah, and even though for most of us, large language models, we interface with those using that simplistic chat user interface, but there are so many automations today, provided by different vendors, or automations that you can develop on your own using tools like Amazon Bedrock, where you can pretty much automate a pretty complex chain of activities using generative AI. And then you have tools like LangChain and Llama Index that sort of like gives developers a massive boost in productivity. So anytime you're thinking of developing generative AI applications, you're going to run into the LangChain framework or the Llama Index framework, and most of those are state-of-the-art libraries or frameworks, whatever you want to call them, that will save you from having to write a ton of code. Okay, so to wrap up this module, we covered generative AI in practice, as well as the risks and benefits. So let's move on to the next. Module 2, planning a generative AI project. All right. So in this module, we will cover the following topics: technical foundations and terminology related to generative AI, evaluating the risks and mitigations with using generative AI, exploring the steps to planning a generative AI project. All right. So technical foundations and terminology related to generative AI. If you've worked with generative AI projects, or have been involved with generative AI projects, or if you've been just curious and have been keeping up to date on articles and research papers, chances are you have come across most, if not all, of these terms. And these terms are actually quite important, because they sort of like, you will not necessarily come across all of those in classic machine learning, but you will come across those in generative AI, more or less. So let's go through them and explain at a high level what does this term mean. So what's a foundation model? Now, remember what we said about some of the key differences between generative AI and classic machine learning? We said in classic machine learning, you tend to be responsible for obtaining the data sets, cleansing the data sets, performing feature engineering, splitting the data sets, training the model, tweaking hyperparameters, generating a trained model. Well, we said in generative AI, all of that stuff has been handled by the vendor, whether it's Amazon or some of the other vendors. All you have to do is consume that model. So when you hear the term foundation model or foundation models, that's a reference to pre-trained generative AI models. Pre-trained generative AI models, whether they're text-to-text or multimodal. So we have this umbrella term called foundation models. And when you hear the term large language models, sometimes people use that interchangeably, but I think foundation models is more generic, okay, and should cover the whole array of the different flavors of generative AI models. Pre-training. Now, pre-training, that's basically how you get your foundation model. It's already pre-trained. All you have to do is consume it. But there are techniques to basically further fine-tune this model or further enhance its performance and its response. I'm going to talk about some of those techniques. The transformer architecture, and the paper that you wish to search for is called "Attention is All You Need." That's a very popular paper. It's called "Attention is All You Need." And I think this is probably one of those research papers that generated so much buzz because it came up with this really efficient architecture. Before the transformer architecture, training recurrent neural networks, LSTM networks, and the different variations, we almost always ran into limitations. Before transformers, anytime you wish to perform natural language processing, you ran into the limitations of the legacy models. First, you could not parallelize the task. With transformers, you can leverage parallel processing, you can leverage GPUs, and there's a near linear relationship. So the more you throw GPUs you throw at a transformer model, the more time you let it train, the better the data. You pretty much, you can see a linear relationship between the performance of the trained model and the number of GPUs, the duration, and the quality of the data, more or less. Okay. With classic NLP models like RNNs, NLSTMs, and so on, that wasn't possible. They suffered from the problem of not being able to parallelize the tasks. Hence, you couldn't basically train them within a reasonable amount of time. It would have been very expensive to train them basically without parallelization. The other issue with some of those NLP models is that they had bad memory. They just couldn't go back in time long enough. They had amnesia. When you're dealing with long sequences, they just forget. They go into it like they'll just start making stuff up. Transformers, on the other hand, not only can they parallelize the training job, and again, you can expand that in a linear manner, they can also retain relationships via attention mechanisms across hundreds or maybe thousands of tokens. Okay. It's really fascinating architecture. Like I said, I recommend that you spend, so even if you don't know the math behind it, just go through some of the research out there. And there are so many videos on YouTube, by the way, that explain transformers visually without the math, just to give you some a level of comfort with how transformers work. Tokens. So tokens is that a chunk of data that transformers work with. A word can be one or more tokens. Okay. So you might come across training that pretty much equates a word to a token, but that's just for the sake of simplicity. But a token, again, is that mathematical. Think of it as the data element that later on will be transformed into, let's say, an embedding, and then that embedding basically is the format that large language models can deal with. Okay, sometimes referred to as vector embeddings. A word embedding, that's when we basically take that word and transform it into a format, okay, typically referred to as a vector embedding. And that's the format, again, that we feed into our large language model. The context is the information that you bundle with the prompt. So the prompt is what you send to the large language model. The context is the information that you send to the prompt. And that may contain not just your question and answer, but may contain the previous exchanges, because large language models by default are stateless. Okay, they're non-persistent. By default, large language models do not retain the exchanges. You need a mechanism, some of a mechanism to retain the back and forth. Okay, so context is basically everything else that goes into that prompt that you can send to the large language models, including maybe the back and forth. So the model can continue to remember the previous conversation. So you don't have to repeat everything, every iteration of your exchange with a large language model. There are a few terms, but I would say those are some of the most frequently encountered terms in generative AI. Now, if you are more technical, probably come across more technical terminology such as stable diffusions, UNets, latent space, and so on and so forth. All right. Oops. Okay, good. So foundation models. So how do foundation models come about? And Amazon Bedrock, by the way, hosts about maybe 2 or 3 dozen, foundation models from half a dozen, top of the line vendors. So Amazon Bedrock, for example, will host, Meta, models from Meta, models from Anthropic, will host models from Mistral, model, of course, and Amazon's own homegrown models from Stability AI and more. Okay, so you don't have to create an environment to host large language models with Amazon Bedrock. So foundation models, they start their life with untrained data. Unlabeled data. So unlike supervised learning, where you prep data, you label the data. Foundation models don't need labeled data. Many of the large language models that you're working with have been trained on raw corpus of internet scale data. Sometimes semi-structured data like Wikipedia, like Stack Overflow. Imagine if you had to sit down and try to structure that the questions and the answers in those data sets. That would be incredibly costly. But the advantages of using unlabeled data to train your foundation models is that you're also picking up all the how can I say, the nuances of human interaction, and that has pros and cons. Okay, but you get to pick up again the nuances of human interaction, of how people interact with each other, and like I said, that has its pluses, but it also has its minuses, and we're gonna touch on that later. So we take this unlabeled data, and then we use it to train the model. Okay, and then we can make that model more of a specialist. So the way we train the model, actually, we can sort of help it, let's say, do better in areas such as content summarization, content generation, code generation, question and answer. Even though it might be mostly the same architecture, and the same architecture, there are things that we can do with training and tweaking to help the model sort of like excel at different areas or different specialties. Okay, now most of the widely available models, again, are generalist models. Okay, they don't know anything about if you have a product and that product has technical documentation, and that documentation wasn't on the web available, it's not public documentation, chances are that large language model doesn't know anything technical about your product. It might know something about whatever public information about your product, but not necessarily any proprietary information. And again, this is where you can leverage retrieval augmented generation or fine-tuning of models to help your model sort of like respond and answer questions about domain-specific information. So pre-training, large amount of unlabeled data, and that data can be text, can be images, it can be audio, music, videos, you name it, right? If we're dealing with multimodal models, chances are, we're training those models on different types of data. So foundation models are trained on massive amounts of general domain data, and there's this ongoing, debates like, which company is basically scrubbing, which other company's data and videos and audio. So yeah, I mean, this is how we train large language models today, mostly on public data sets, massive public data sets, and that's called pre-training. Okay. Some of that data, by the way, is available to you, so you'll be surprised how much of some of this public data is available for free. Some of it can be licensed, okay? But where areas of contentions basically come into play is, when some of those large language model vendors basically sort of like start, collecting data from, paid content repositories. And that's where we're seeing, this relationship hopefully will stabilize at some point. So we're seeing some back and forth today, but at some point, hopefully we'll have, some sort of a protocol for how large language model vendors can consume non-public domain data, or to some extent also public domain data. So we said that transformers are those amazing evolution of neural networks that allowed us to efficiently train models that can process natural language, okay, at a level that's been unseen before with classic NLP models like RNNs and LSTMs and more. So memory efficient and can be trained in parallel on GPUs. We talked about that. We can literally chunk the tasks at scale. And we said there's a linear relationship that did not exist before transformers. So in the past, before transformers, you can have 100 or 1,000 or 10,000 GPUs, but you were not going to achieve this massive acceleration in training before transformers. With transformers, you can achieve that. Able to retain and use information about meaning and position in that latent space. Transformers are so smart and so sophisticated, they can actually establish complex relationships. I mean, you can think of it as a 3D space. It's not actually, it's more complicated than that. You get a 3D space where different words and different tokens sort of like maintain proximity to other words that are related to them. So you have these clouds and subclouds within this massive cloud of words and tokens, where these subclouds contain, let's say, words that are related to each other in this cloud. And we use, let's say, algorithms, such as cosine similarity, Euclidean distance, to sort of like, find out, which word or which words are closer to a token of interest, okay, or word of interest, and sort of like expand our search and retrieval. And to oversimplify the job of large language models excel at something, by the way. They excel at guessing the next token. If you want to really simplify large language models excel at guessing the next token and the next and the next and the next. And that guess isn't based on just the previous token or the previous word. That guess for the next token go all the way back to, I don't know, sometimes hundreds of tokens, sometimes thousands of tokens. Again, that goes back to the transformers and the attention mechanism. It's quite sophisticated stuff that you just couldn't do with, like I said, classic NLP algorithms and models. All right. So here's an example. Actually, yeah. So here's an example, input. What is an example of how generative AI works? So let's take this sentence. I like this example, by the way. Let's take this sentence. A puppy is to dog as kitten is to. Remember we said large language models are super at guessing the next word, okay, or token. So let's see how, let's look at a very simple examples of how large language models work, or transformers. This is a great example, by the way. So first thing we do, we take this sentence, okay, and then we generate tokens. And a word can be a word can contain more than a token. So it's not a one-to-one relationship, okay? So a word can be one or more tokens. But here, again, for the sake of simplicity, we're just mapping a word to a single token. So we break this down into tokens, okay? And then we encode these tokens into, let's say, call this our vector space. Now, and again, for the sake of simplification, we are going to create this 3D cloud of words. 3D cloud of words. And based on the proximity of one word to another tells us that there's a stronger relationship. So the shorter the proximity between this word and this word, it basically tells us, yeah, there is a relationship here. There's a closer relationship between cat and feline than between cat and canine, okay? Like I said, it's not 2D or 3D, but this is just a simplification, okay? So word embeddings are 3D dimensional vectors that represent a word. Word embeddings are encoded to capture contextual information, including positions. So it's actually much more complicated than this, okay? So it's not just about proximity to, between two words. It's actually the relationship between multiple words are also retained. It's a very complex relationship. And this is why large language models, when they guess the next word, they do an excellent job of that guess, because during the training process, they actually have insights into what goes back way, 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 way back. And this is why their guesses tend to feel more human-like, tend to feel more human, because they do have this memory that is based on text that was generated by human beings. So the relationships aren't just, random. The relationships aren't just, something that the model says, okay, you know what, I'm just going to establish, that this word is closer to that word. No, it's actually based on how humans interact. And that's where we get, this human-like, okay, response from large language models. And there are many algorithms, by the way, to determine, the next probable word and generate that to complete our sentence. Like I said, some of those are cosine similarity, Euclidean distance, but there's a whole field that actually even predated large language models, where vector databases existed, and they helped in optimizing search engines and so on. So we take this, let's complete this example. So we look at this 2D diagram, for example, and say, okay, sorry. Let's look at the coordinates. A puppy is to dog as kitten is to. And if we look at our diagram, we find that, a logical response is kitten is to a cat. 9.2. Okay, 9.2. That's the prediction number. So a puppy is to dog as kitten is to cat. All right. So context. So going back to the input that we pass to the large language model. So context is the text in the current active conversation you are having. That's a really nice, simple definition. It does not persist, and it has a maximum size. So large language models are not persistent. They don't have memory of exchanges. You enrich the context with your previous discussions. So this way, the large language model pretty much has some memory of the conversation that transpired between you and that large language model. Without keeping context, the large language model will always assume that you're asking questions from scratch every time. And this is where libraries like LangChain and Llama Index, by the way, come in handy, because they can help, amongst other things, simplify the process of retaining this back and forth between you and the large language model. When you work with a chat interface for some of the popular large language models, there is code behind the scenes that's keeping track of your conversation, by the way. It is not the LLM that's keeping track of your conversation. It's this wrapper code. Okay. So if you want to simulate that in your application, if you want that feature, you probably rely on frameworks like LangChain and Llama Index. And yes, each model has a preset input size and preset output size, and you cannot exceed those. So some models allow you a maximum of 512 bytes input, and something like 512 output. The more recent high-end models actually are quite generous with their input caps. Some of them claim to have 200K or somewhere in between, and we're seeing that number go higher and higher. And that has some implications, by the way, on how you architect your generative AI applications. Like, do I put my data in a store, or do I just ship it, with my prompt? And of course, there are cost implications and performance implications. All of these you have to basically sort of like balance. So how does context work? Again, programmatically behind the scenes, it's quite simple, whether you write this code or use tools like LangChain. So prompt, turn one, hi, what is the best place in Seattle to visit? So you ask the LLM, you send it this question, okay? Response, the Columbia Center offers breathtaking views of the city skyline. Now, if you are not retaining this context, if you're not keeping track in the next message that you sent to the LLM, if you're not keeping track of the previous question and response, the large language model will not know the meaning of this question. Will this be fun for children? If your context that it doesn't have this information, the large language model either will hallucinate or will say, what is this? I don't know what you're talking about, okay? But because we are keeping track programmatically of the back and forth, then we are helping the large language model understand what this refers to from our previous discussions. So large language model, non-persistent.
Hey, Mike, we
Yeah.
had a question in the chat. It's
Sure.
How can we determine the model accuracy? It's going to be
There
below
are actually,
100%.
okay.
Yeah.
There are actually benchmarks. There are benchmarks that are widely used that you can run against your model. There are actually leaderboards, some hosted by, let's say, names such as Hugging Face, that will constantly evaluate new releases of large language models against some of those key metrics. And this is actually the most objective way using these metrics to assess the accuracy of a model, and it's going to be relative to other models.
Yeah.
So there are some benchmarks that use maybe like some absolute references, other benchmarks that will basically just compare one model to the other. But for example, let me actually, do you have like a minute for me to show that, Miles?
Not really.
Okay,
But
okay, let me, yeah. But if you Google Hugging Face large language model leaderboard, you will come up across multiple actually leaderboards. That what they do, they use, like I said, industry accepted to some, more or less benchmarks to assess the quality of a large language model.
Now that's for the model as a whole, but given a given prompt, there's no way to tell like how accurate is this specific response to this prompt.
I mean, you can, if you are asking to gauge the accuracy of, let's say, domain-specific responses, sure, you can write test cases. I mean, you can actually build those test cases into your system. So every time you release a new, let's say, fine-tuned version of your model, or a new prompt structure, you can actually create a battery of tests and compare the response against those. I mean, that definitely would be the easiest way to do it. So this way, you're not leaving it to third party.
That makes sense. Okay, so I think we have time for just that one next section about planning the project.
Okay, got it. So I'm at slide, let's see.
45, I think.
Oh, 45, okay. So planning a generative AI project. So define the scope, select the model, adapt model, and use the model. Of course, these concepts apply to any development project. There's nothing new here. You always have to ask the customer what they want, and the customer can be internal, can be external. The scope is pretty much depends on customer requirements, budget, technical know-how, the team's ability to basically absorb and leverage generative AI skills. Okay. So yeah, a number of variables go into defining the scope. Typically, some companies go for easy wins first. To say, you know what, I just want to test the waters. I don't want to go and touch my mission critical systems. So I'm just going to go with some proof of concepts, MVPs, and I'm going to go, let's say, maybe for some like internal chat system for HR, or something where if something goes south, it's not going to have a negative impact on my company's line of businesses, and so on and so forth. Or now we're seeing companies saying, no, we are investing heavily in generative AI. It's with the future. It's not just basically some fad. And for all practical purposes, generative AI is going to stay with us. I mean, for all indicators, I mean, whether it's on a personal level or on a corporate level or a societal level, generative AI is here to stay. So some companies are basically saying, you know what, we're going to be early adopters. We're going to perform robust planning. We're going to think strategically about generative AI. We're not going to basically approach this, as just a small experiment here and there. It's almost like how many companies approach the cloud. Some companies sort of like, tiptoed around it. Other companies said, no, you know what? We're just going to go make a strategic decision, and we're just going to move to the cloud. Same thing with generative AI. So we're going to see companies going the easy wins, and other companies going basically the strategic path. So which model is right for you? Again, you have all sorts of models hosted by Bedrock. You have, like I said, I mentioned some of the names. But I guess if the pre-trained models are not good enough, you can fine-tune the model. You can actually let it perform additional training on it using your domain-specific information, so it can answer questions about your domain-specific knowledge. How do I adapt the model? Two ways. The easy way, well, relatively speaking, I think that's the way that doesn't involve you modifying the weights of the model. It's called prompt engineering. And like I said, there's actually now a domain called prompt engineering. And there are so many repositories for prompts, and there are so many research papers that measure the outcome of an LLM using a certain prompt versus another prompt style. But if you want to go beyond prompt engineering, you can go the path of fine-tuning, and that's when you actually further train the model and actually impact the weights of that model. That's called fine-tuning, and Bedrock allows you to do both. Amazon Bedrock supports both, again, with nominal code or no code in some situations. So consider using the solution. Have you managed all of the responsible AI concerns? Responsible AI concerns, it's a very serious matter. And now we are seeing the EU, for example, we're seeing different, let's say, government entities, moving forward to basically create certain guidance. Some are loose guidance, but some are quite strict, okay? And there are so many documents to cover the subject of responsible AI. We have issues such as bias, such as privacy, and much, much more. So there are solutions like in Amazon Bedrock. You can actually create filters, aka guardrails, to sort of like mitigate many of those concerns, okay, and require minimal programming. Do you have a plan for feedback from users? Are you incorporating that into your generative AI application? And of course you should, because sometimes the ultimate feedback will have to come from the users. I mean, this is how some of the leading large language models evolved. They used user feedback. They relied on user feedback to basically catch responses that are, biased, that are, crazy, that basically might have leaked, PII data, and they just evolved over time and tightened their guardrail. How are you tracking changes to the pre-trained model? And then this goes to the topic of the evolution of ML ops. So now we're seeing something called LLM ops, Gen AI ops, and yes, because now you're dealing with maybe a different side of the pipeline than the classic machine learning pipeline. Because now you're engineering prompts. You want to keep track of your different prompts. Now you're fine-tuning models. Now you're employing vector stores. Now you are deploying code for your RAG, maybe for agents that you may wish to invoke to basically interact with external tools. So your classic machine learning model, ML ops pipeline, needs to evolve and adapt to the new stages that you will basically put in place to develop and deploy generative AI applications. Okay. All righty. So I think we're out of time, so I'm going to hand this over to back to Miles. So thank you all again for attending, and I think Miles will take some of your questions here.
I think you could probably finish off that last little.
Okay.
Then yeah.
Okay. Awesome. Let's do that then. Thank you. So evaluating the use of generative AI for your project. Okay. Common risks of using generative AI and how to mitigate some of those risks. So what are some of the generative AI considerations? Fairness. Fairness is a key issue. And the simplest example that you will run across, by the way, today, if you let's say deploy some of the generic stable diffusion models, and you pass a text prompt to it that says, hey, generate an image of a doctor, generate an image of an engineer, generate an image of let's say an astronaut. I've tried that so many times, 99 chance that you will basically get a male, figure, unless you go in and specify, give me an image of a doctor, male or female doctor, or give me an image of an engineer, male or female. Then, you will have this, something like a random, generation of gender, and extend that, of course, to other areas. And yes, not all, and it's very difficult, by the way, for developers of large language models and trainers to sort of like anticipate all the responses without active guardrails. And active guardrails, that's when you basically have code in place or people in place, humans, experts, that inspect the responses before they reach the customer, okay? And code that evaluates the output before it reaches the customer. And again, Amazon Bedrock has this built-in guardrails that can help you sort of like mitigate some of these issues. Privacy. It is important that the model not expose private information. And large language models are getting more and more sophisticated when it comes to protecting PII data. But still, you might also need that additional layer. For example, if your data repository for your retrieval augmented generation solution sits in an S3 bucket, AWS has tools such as Macy and other tools that can actually catch and mask PII data, or catch and flag PII data for you to take action. Okay. You can also put guardrails on, again, there are 2 points where you can basically establish guardrails. On the input side, data sent to the LLM, or on the output side, data generated by the LLM on its way to the customer. You basically have like some sort of an inspection layer. to look for, all your, list of issues that you wish to intercept before the content goes to the customer or the application that will then process it. There are actually applications out there that can, and including Amazon Bedrock's guardrails, where you can sort of like catch or measure or assess the following: toxicity. Well, hallucination is a bit difficult because some models can actually make up stuff and it's pretty convincing. And this is where you have to go in programmatically and create, test sets, especially when talking about, domain-specific data, because you know what the response should be. Okay. Intellectual property, that's an ongoing issue. There are cases that are being actually litigated in court. Hopefully at some point, the industry is going to have some clarity. Plagiarism and cheating, disruption of the nature of work. And yeah, I mean, one of the more obvious implications of generative AI is that it is changing our, workflows. I mean, me personally, I mean, I rely heavily on my favorite large language models on a daily basis, for my email generation, for my summarization. I don't have time to read academic papers, sometimes, so I'll send 5 or 6 of them and basically get the gist and look for things of interest. And yeah, it's literally part and parcel of my daily admin activities. All right.
All right. Okay. If you can stop there, I'll share my stuff. Well, thank you, Mike. Really appreciate that. There will be a recording sent in a few days. I'm not sure when it comes out, but you should get a link to the recording. We're not allowed to share the slides. That's sort of part of the deal AWS gives us. If you want to know where to go from here, there is a 2-day class that really takes this hour and a half and blows it out, and it's a much deeper technical kind of thing. That's called Developing Generative AI Applications with AWS. We run that probably, maybe once a month. It looks like September, October, November. Yeah. And that's a 2-day class. It has some labs now. But most people need to know a little bit about AWS before they jump in. So if you're brand new to AWS and you just want to get some hands-on, we have the 1-day Tech Essentials. We run that, almost every week. To get a broader view of the various AWS services, the best classes, the architecting on AWS, that also runs fairly often. If you want to know more about the data analytics stack, we have a series of 4 1-day classes, or we also package it up as this 4-day class. So September 17th to 20th, you see it runs maybe every 6 weeks, something like that. So those are all classes that, if you go click on, say, the generative AI applications, this will take you to the ExitCertified website. And if you go down and read more, you can see the skills gained and, prerequisites. Ideally for this class, Python a little bit already, and hopefully a little bit about AWS. So that's the prereqs. If you took the 1-day Tech Essentials and Python, then you're good to go. Mike teaches this class for us all the time. It's a 2-day class. It just goes much deeper into the technical stuff that he hit on today, but didn't get too deep into. And actually, I'm going to put just this URL into the chat just so that you have it. So if you're looking for any of our AWS classes, this is where you'll find them. And I guess what else do I want to say? We also have other Gen AI classes that we build ourselves. If you really are trying to make that jump from a machine learning data scientist type person to really get into heavy duty Gen AI engineering, you're building your own large language models. Our sister company, WebAge Solutions, has a lot of these kinds of classes. So if you're if you're really AI developer, we get into these classes. We have an intro, an intermediate, and then there's like a comprehensive kind of generative AI for developers. There's all these kinds of classes. So let me throw those in there as well. Just the WebAge classes. We actually have until the end of August an AWS promo So if you're looking to take maybe the Tech Essentials or the Architect class, let me throw that link to the promo. It's basically, if it's a 3-day class, you can get $300 off the class. If it's a 4-day class, you get $400 off, up to $500. Any of these classes you see, if you don't like the dates, if you've got, maybe 5 or 6 people or more, we could put on a date just for you, right? We do in-person classes as well. Like if you want us to send the instructor to your place because everybody's in one place, we'll do that. Most of our training, we use Zoom to do, sort of virtual training. It's a little like this, but it's a little bit more interactive because, of course, everybody's got two-way audio video. These ones we want to open up because, we had almost 200 people register. So we do just the chat. But our regular classes are, we try and mimic like an in-person experience, even if it's virtual. And if you're, if we're putting on a dedicated session for you and you don't want to use Zoom, you want to use Teams or WebEx, whatever, we'll use whatever you want. Right? The other thing to mention is Mike's doing another one of these discovery days, August 7th. That's next Wednesday. Yeah. Same time, 1 p.m. Eastern. It's called Intro to Prompt Engineering. And he sort of mentioned a little bit about prompt engineering, but the idea that it's, kind of a growing thing. And so if you're interested, let me just put that URL in to the chat as well. And you should be able to just click on it and just go and enroll in it for free. So I think that's most of the housekeeping stuff I wanted to do. ExitCertified. Whoa, I didn't mean to click on that. Oh, that takes us to the website. So ExitCertified obviously is partnered with AWS for training, but also, Microsoft, Google, Oracle. So, whatever your public cloud training needs are, we've got you covered. But then all these other topics around cloud, we do those things as well. So I just wanted to kind of hit that home. And actually, when I click on this takes us to our cloud-centric diagram. Let me just throw that in here as well. If you're interested, if you decide, oh, okay, well, we want to learn about Kubernetes or something, you click on that. That takes us to our offerings on Kubernetes. So we do quite a bit of stuff. I guess last thing to mention is both my and Mike's email addresses. So here I've got that. Let me just copy Mike's in because I know people came in after I put it in the chat, and I'll put mine as well. If you have questions specifically about, Gen AI stuff, then send it to Mike. If it's more just about, upcoming AWS classes or something, you can send it to me and I'll get you in touch with the right salesperson. And I think that's about it. I wanted to thank AWS for making this content available to us. Thank Alan for giving us a quick intro and reminding people that, ExitCertified is sort of one of the biggest authorized training partners in North America, if not the biggest at this point. And I wanted to thank Mike for giving us that quick intro, sort of higher level intro to the Gen AI offerings, especially the ones on AWS. And we hope to see you in next week's webinar or, somewhere down the road in a course. I think Mike and I will both stick around for a couple minutes. If you have any questions, you can throw them in the chat and we'll tackle them. Otherwise, I think we're starting to see some people disappear. Yeah, we are. Well, we were supposed to be sort of 1 till 2:30 Eastern. So I'm sure people have things that they got to jump to. But if you want, we'll stick around a little bit longer. All right, Mike, just seems like everybody thanking you and not a lot of questions. So I guess we'll shut it down then. Thanks a lot, Mike. Oh, you're on mute.
Thank you, guys.
All right.
Thanks, Mike. Bye-bye.